Welcome to the Kern Competence podcast, a podcast by Kern about all things Kern and precision. Today I'm joined by Christian Meyer. Christian is working in our development. It's a rare thing to get one of our developers to join me for a podcast. So, Christian, a very warm welcome to you.
Hey Marvin, how are you?
I'm really good. It's pretty late in the day and you look a bit tired because, we all know there is a big bird in the room. Okay, not in this room, but I'm also quite knackered already. Exhibition preparation is tearing at us.
Yeah, Marvin, you're right. I am a little bit tired, but I try my best.
Okay, very good. I've known you for a couple of years now, but our dear listeners don't know you yet. So I would ask you to kindly introduce a little bit about yourself. Where do you come from?
I introduce myself. My name is Christian Meyer. I'm born in Munich. I went to school, and later we changed the town. We went next to Fürstenfeldbruck, and
Also in Bavaria?
Also in Bavaria, and later we changed in the south of the lake Starnberger See.
Which is already approaching Upper Bavaria and quite close to Kern.
Yeah, and right now I live in Großweil. It's a town 10 kilometers from here. So,
tell us a little bit about your professional or your academic formation. Where did you learn?
Maybe it's a little bit funny. After school, I started as a carpenter.
Okay.
So I built tables and chairs and kitchens and stuff like that.
Did you do an apprenticeship as a carpenter? Ausbildung?
Yeah.
Yes. Okay.
Yeah, I did. I finished it, and after that I was working some months as a carpenter. But for me, I thought, that can't be all in my life. I have to do something different. Then I started studying wood. It's wood technique. It's kind of
technology of wood. Yes.
Technology in wood. How you build the machines for so some wood. And there we had one Ausflug.
Like a tour?
Well, a tour with the university to
Excursion.
A company which develops and builds machines.
For
milling
manufacturing
machines.
of wood?
No.
Okay.
For manufacturing, for milling. For
which company was it? Do you remember?
It was Alsmetall.
Alsmetall. Oh,
Alsmetall.
Okay, yeah.
Yeah, and then I changed my mind. I what are you doing? You're studying wood technologies, and what can I do with that? And what do I have to learn to develop and build and use such machines?
Okay.
And then I checked how I will be ready for this, and so I decided to change from the wood technology to mechanical design.
Okay.
Yeah.
You do know if this was like a Marvel movie, this would be your villain origin story, you know?
Yeah.
The moment everything transformed.
Yeah.
Okay, yeah.
Yeah. So
did you study in Munich?
Yeah, I studied in Munich, not at the TU, at the Hochschule Munich. Yeah, and I think I quit studying 2014, and the graduate was diploma. Still diploma. No,
Okay.
it's bachelor and master.
Now they would call it masters
Genau.
nowadays in Germany, but back then was the diplom engineer, the very well-renowned German diplom engineer. Okay.
And so I'm working almost 11 years at Kern Microtechnik.
So you started after studying?
Yeah, the Kern was my first company, and I started not in the R&D.
Okay.
I started in the application.
Oh.
There at the beginning there was a different structure in the applications. So we had a small department, it's called PAV, Precision Applications, and I started as a system engineer. And 1 year later, I had chance to change to the research department. With the task to develop the micro HD.
Yeah, it's really cool. I know that I started a couple of years after you when HD development was already pretty much finished, but you kind of were the project lead on micro HD already.
Yeah.
It's quite the steep rise at Kern from like engineering applications to becoming project lead on the most important machine we probably ever built. Very cool. I think this is a really nice lead over, and we probably have to do a second episode at a later date to talk about the development of the HD. Yeah, the reward for good work, for example, a good podcast is always more work. So you should have expected this. Let us talk a little bit about Fortis HD. Simon and I have already spoken one full episode, and we teased it in an episode before that big new machine is coming, Fortis HD. Internally, we haven't called it Fortis at Kern. Your team and you gave it a project name, a working name. Please tell us the name and explain where it came from.
Maybe before giving an explanation for the name, maybe we start a little bit before, if it's okay.
Yeah, sure.
Tell something about how it comes to the project. Maybe.
We can also start with that one, yes.
Oh, okay.
Sure. Okay. I mean, Simon and I spoke a lot about how at Kern we pick up customer requirements. So we are talking a lot with our customers. We are actually listening to them. At least I think I do. I'm not sure whether Simon is always listening, but we are listening to the customer and they can give us input, and we are also looking at the market. So we came up with this idea of it being a big machine. Now, if this was a large mega corporation, you would probably have been given a design control grid and told to get to work. How did it work here? How did the project start?
To be honest, it was different. We at the beginning we had some meetings. Where we decided, okay, we want to build a bigger machine. And what I got from the meetings is, okay, Christian, we want a machine which has the same accuracy like the micro HD for bigger work pieces, maybe like for parts who fits on the UPC clamping system. That's it.
Nice.
No design control grid, but wasn't really a problem because...
I mean, it sounds nice. It's like a blank canvas you can start.
Yeah.
Did they require you for it to be hydrostatic?
Yes.
That was one of the requirements as well. Okay.
Yeah. This was a hard requirement, yes. Yeah, and so with the project, Albatros was the internal name.
Nice.
Maybe I explain later why Albatros. It was also the first project at Kern in which we wanted to introduce a new process for introduce new products in Kern. It's called NPI process Kern. New product introduction. And we started with this project. So at the beginning, I also had to make a plan. How could this process be? Yeah, and how is it?
So they required a couple of boundary conditions from you. How much work will be done on this? Probably?
Yeah, how much work, how much money, what are the different phases, what especially what milestones, what is really important for the feasibility phase, and so on. Where are the risks?
Did you have to sign one of those fancy NPI contracts?
No, I don't know them.
I think I'm the only engineer they ever had to jump through those hoops where you actually sign a contract with like the management that you're developing something.
I wrote the project card at the beginning. Its project is called ABC. And yeah, it's just one pager, and you sign it, and the management signs it.
You did sign one of those.
Okay. With the Albatros project, it starts.
Okay.
So yeah, and hopefully, I can tell something about the MPI if you want.
We already did an episode with Sebastian about that one. So if our listeners go back to season 1, they will know a little bit more about that one. I think what would be nicer to know is you got this really blank canvas. You got told, okay, it needs to be hydrostatic. It needs to be bigger. You got told like a rough size. It needs to be 5 axes. I think this was never without question. And how do you go on from that moment? Like what is the next step? Like even before setting up that NPI process, you probably sat down and brainstormed with a couple of people?
At the beginning, yes. And then we checked the market. How are the machines which are ready for UPC clamping systems? How much travel space?
Maybe to define it for our listeners, UPC, that's like the Aroa, the large Aroa pellet.
Yeah.
I think it's 320 by 320, but it doesn't mean your part needs to be limited to this one. Just like with our current ITS 184 millimeter pellets, your part can be much larger, but this is the pellet interface for the robot and for the 0-point clamping on the machine.
So with this information, we checked the whole market, especially our competitors. Like Redas or Makino. Also Grob, I think, because bigger machines need to have more productivity. So Grob is also
Did you ever consider building a horizontal machine?
Yes.
That would have been awesome.
We were thinking about this.
Okay.
So we analyzed the market, and after that we were able to get some values. How big?
Just like some performance indicators, what the machine needs to be able to
which
do.
kind of spindle is useful, how many tools, the weight, and on and on. We were able to write our own design control grid.
That's actually really nice.
Yeah.
Okay.
And after we had the design control grid, we talked about with our management if it's okay if we go in this kind of direction, and said maybe a little bit more there, and so in the end we had a complete design control grid, which was the base of our whole development. And
how does one start development there? Do you, for example, start with like a small mock-up of the machine, like in SolidWorks, and then start adding details, or do you get to work on like individual groups of components? So is it like a bottom-up or a top-down approach?
It's a mix.
Okay.
It's a little bit mixed. We knew from our other machines what we have to include to the machine. Like, okay, we need a spindle, we need a tool changer, we need a fourth and fifth axis, and some aggregates for doing something. And so it was the structure from the different machine parts or components was clear from the beginning. So I made an overview on a white paper with a pencil and wrote, okay, we need spindle, like I said, we need the hydrostatics, the linear axis, we need the linear drives, the weight balancer, and so on. And with this, I was able to see how long it takes and how much money will cost, or what's all included in the project. And the next step was to take the different parts and give it to some people in the company, some employees who were defined before. It was in the meetings before the project officially started. Okay, how many people do we need? And they all got their task. And at the beginning, there was no CAD. Just write it on papers, because we were in the planning, in the step from the planning to the concept phase. And so we had a lot of papers with sketches. So to decide in which direction do we want to go. For example, one big decision was, let's go for the same concept like the micro HD, kind of kinematics, or should we do something complete different, which maybe has more risks. In the end, we decided for the micro HD.
Okay. Yeah. I mean, I know that we can't really define like what is your team, because most of the developers that worked in your team on this project, they also worked on other projects.
Yes.
But overall, how many people do you consider, if you can put a number on it, consider to be your core team that worked with you on this?
I think at the beginning, it's not the core team. We defined, I think, about 16 team members, but over the whole company. So with also like people from marketing or sales or service. So 16, and the core team, I think the core makes one electric part, Heike Diegel, one designer, constructor, Andreas Lehnerer. He was very important in the development. Another designer, Johannes Wittmann. A guy you really know, but it's at this moment he isn't in the company anymore. Maybe you know him, Benedict Cavalier.
Yes.
He had the project Spindle
He's now building hydraulic systems for cranes or for excavators, something like that, right?
Yeah.
Okay. You cannot escape the oil.
Yeah. Yeah, he had the project for, or the task to develop spindle and the swivel and rotary axis. And also an important guy comes later in the project, because in the beginning you don't need the software, but you have to talk with them that you want to build like that, so that they know what they have to which program they have to do. So 5,
Okay.
6, maybe 6 people at the beginning with me.
Really the core team.
Really the core team.
A larger range of people you could get access to help you. So, for example, I know Christoph Steitmeier from Applications Department was hugely involved. Things like that. Okay. What are some of the challenges you faced? So, I mean, this is a huge project, and I don't mean it as a joke because the machine is huge, but it's more like I would probably say this is the biggest machine we've ever built.
Yes.
It's larger than the Pyramid Nano.
It's larger in the dimensions
and also in the complexity.
Yeah.
So maybe talk us through a couple of challenges you faced there. For example, maybe let's talk about the motion system. It's hydrostatics, but it's not the hydrostatics from the HD. Obviously, you couldn't take those.
Yeah, you can't take the same hydrostatic from like the Micro HD has.
Why? Good question there would be why. Why can't you just slap the hydrostatics from the HD on a larger machine?
Yeah, you have different kind of moved masses. You have bigger forces or other forces.
Our listeners can't see Christian's face, but he's currently looking at me like I'm a little bit stupid for asking that question. So the question is for the people not as deep in. Problem is scaling. So you cannot take technology. This would be just like taking a very tiny bicycle tire and putting it on a motorbike. It doesn't work. You can't scale. So developing new hydrostatic technology.
Yeah, it was at the beginning. We also made a list of all the risks and challenges, and to scale the hydrostatics with the linear motion system was a big challenge, because we wanted to scale the micro gap hydrostatics, not the standard hydrostatics with higher gap sizes. Wanted to scale the micro gap sizes, and so you have different challenges with the to get the parts with that high accuracy you need for the small.
Because typically, for example, the flatness of your guideway needs to be within a certain range of your film height, right?
Yes.
And let's, for example, say if it needs to be 20%, obviously, if your guideway is much smaller, this is easier to achieve a good flatness than having the same flatness as a large part, right?
Yeah.
Okay.
So it was a hard fight with our suppliers to get this, and we needed to train them.
Okay. Did you? I actually don't recall. Did you put up a test bench for the hydrostatics?
Yeah,
you did.
We did, especially for the bearings on the side.
Okay.
We have kind of amount of bearings in each linear axis, and especially at the side bearings, we made a big change compared to the Micro HD.
Okay.
There we built a test bench to check the feasibility, and in the end we were really happy that the test bench worked, and with some improvements, it was able to bring the technology from the test bench to the machine.
I would imagine that's quite the exciting moment, isn't it? Because, I mean, for the test bench, you manufacture kind of some mock-up guideways, and you manufacture the pocket technology and the restrictors, and you set up all of the hydraulics and everything, but it's all put together and you don't know whether it's working. And then I imagine, I wasn't there, but I imagine it's kind of like flipping a switch and seeing whether it lifts off or not.
Yeah.
And is this a real risk?
Yes. Yes.
And did it lift up?
It lifted up.
That's really cool.
Imagine years, or it was years. You did all the calculations in the different parts, how they move, how they bend.
And I mean, this is not only like simple FEM simulation. This is not like you click it together in ANSYS. Are we using ANSYS?
We're using ANSYS.
You not just click it together in ANSYS and it can calculate the whole model and tells you, yeah, this works, right? It's more complicated than this.
Yeah.
Okay. So
because you have additional, that's one part. You have to use ANSYS to get the risk a little bit down. But you have the manufacturing tolerances too, for example, and there are more things need to be done. And for me, the moment where we switched on the aggregate to lift up, I think the first axis was the x-axis. To lift up the x-axis, it was very special, and I was excited because I did all the calculations and will it work or not, and after it worked, I was very happy.
Okay. Yeah, I can imagine. Please tell me, I guess you didn't, but please tell me you did like a space flight control base with a countdown and then you said there was liftoff? No, you didn't.
No.
Oh, okay. This is a missed chance. Yeah. Okay. I could imagine that this was probably like the technological most advanced single event happening where you were like, oh, this is really a win. But there were some larger component groups you also put together. And I imagine this is also quite difficult to simulate. If you have let's say you have a tool changer and the gripper for the tool changer is easy to simulate. But if you want to simulate the whole tool changer, that's probably horrible. Were there any other like larger component groups where you were like, okay, this is really a challenge and something we did differently compared to the HD?
Maybe let's go out of the group. Just go one step before the axis lifted. It was lifted. Just to get the part as a part, I mean, for example, a y-axis or a z-axis in this kind of dimensions. There was a huge risk to manufacture this part. We have many different steps in this aluminium parts.
So the axes are still cast aluminum?
Cast aluminium, yes.
And Simon, I think he teasered in the last episode that it's 2 tons of weight, XYZ.
About a little bit less, but
yeah. So maybe for our listeners to get some sense for the dimension, because you and I have seen the machine, we've seen the dimension of the y-axis, but the y-axis body, can you tell us like just roughly what length it is, what width, and like how heavy it is?
Roundabout, it's 1.4 meters long, 800 high, and 600 wide. And it's about 700 kilos.
Okay. That is a massive part for casting aluminum.
Yeah. And with the information that it was the second bigger aluminium part, casted aluminium part Kern ever designed. The first ones were the parts from the Micro HD. We did it really well because we could use the first part for the first machine.
Nice.
Yeah.
Okay.
So this was also a grateful moment to see the parts the first time. Yeah, followed from the moment where we lifted them up.
I mean, for me, this was always like we talked about your villain origin moment, and mine kind of was the first time CNC milling something, and something you only envision in your mind became reality. And I can imagine that this feels on a much larger scale, feels also very gratifying when the parts arrive at the factory and you can really see them. It must have been really cool. Did you actually see them outside the factory first? Did you go to the casting supplier?
Yeah.
Oh.
Yeah.
Nice.
We've been at all our suppliers.
Okay.
Who make the important parts.
Okay. Did they ever tell you no? Were they like, yeah, you can't cast this? Or were they always like, yeah, we can do it?
It was different. The suppliers who would deliver us the parts now, some of them said, you can't do it like this. And then we made changes so that they can do. And there were some who said, it's no problem. But with the other side, having the opinion from the suppliers said you can't do it, we didn't believe the others, so we decided to go to the guys who
I think this is a very valuable moment for suppliers of ours listening to us too here. If you want to sell something to Kern, you have to tell them it's not possible and suggest a different way, right? Then we buy with you.
That wasn't the only reason.
Okay. I can imagine. Okay.
So you told me that for you the one big moment in the project was to see the first milling of the machine.
Yeah.
Is it possible? Is it not possible? At this time, some people told me, Christian, are you excited? Do you think it will be able to mill something? And for me personally, wasn't that special moment because I was sure it will work. Because what happened before we measured the whole parameters from the machine and we checked them, and so for me it was clear that it will be able to mill. And
I mean, this sounds very confident, but something I know our listeners don't know is you actually were on vacation when we did the first chips. You were like so confident it's happening, you were on vacation. And I know very well, people asked me like, hey Marvin, can you hack a post processor together so we can like run a Trojo idle milling program on that machine? And I was there with Christoph Steitmeier. So Christoph Steitmeier and I, we were the first two people milling on it. And I kind of looked around and was like, hey, where's Christian? Why isn't he here? And everybody was like, he's on vacation. And we're like, shouldn't we wait for him? And everybody was like, no, he said it's good. We can do milling. We actually have video footage. I sent it to you in your vacation back then. We have video footage of the first chips. It's quite the beefy cut with an insert cutter already. And I also kept the chips. We have the first chips of Fortis.
We have it there.
Yeah, we put them in a box, but I'm hiding them very well away. So you kind of need to pay me to give them to you. I mean, for us, this was a really cool moment because I'm, from all of the stupid questions I'm asking, I wasn't very involved in this problem at all. I was mostly sometimes doing a bad joke about it, but. And when we took the first chips, I was like, hey, people, this is an historic moment. For me, it had more weight than for you. And I told them, hey, we're going to film it and please don't talk over the recording. We want some sound of the machine, of the first chips hitting the enclosure. And it's kind of funny because you had like the 6 or 7 people from your core team standing around, and Christoph and me operating the machine, and the camera was rolling, and everybody was silent for like 10 seconds, and then everybody started high-fiving and shouting because they were so happy it's working. That was a really cool moment, to just like see it make chips. And you weren't there. I'm a bit sorry. Okay. Yeah, very cool. I think another major change in the design of the machine compared to the HD is not only the hydrostatics, but also the cooling management. And here I don't mean the coolant management, but like cooling the actual machine parts.
Yeah. Maybe not a huge change. If you know the micro HD, you know the area where the cooling aggregate is. It's an area next to the machine.
It's a separate aggregate. Yes.
Yeah, it's a separate aggregate. You need a separate space next to the machine. At the Kern Fortis, we decided that we want to integrate it under the machine, at the back of the machine, and this was a very tough decision with many consequences, because it was really hard to make the design that it fits under the machine. Everybody said, "Are you crazy? You never get it under the machine. It will never work." But I had no we decided this, and so we just
Did
it. Yeah. And now it works, and it's pretty cool. You have nothing next to the machine. You have all the aggregates for the cooling, the axis and the spindle, and the supply for the hydrostatics under the machine. If you want or if you need, you can pull it out.
Okay.
And make some service or something. Take a look at it.
Okay.
How beautiful it is.
Okay. Yeah.
Without stopping the process on the machine.
Nice.
So if you take a look at it now, I think everybody says it has to be like this.
Okay.
Nobody would make it different. But we had this picture at the beginning.
I can imagine that's quite the challenge.
Yeah.
Typically, like you stack everything in the hydraulic aggregate, and for some components, for example, the pumps, it just makes sense to stack the pumps on top of the coolant tanks. And I would imagine if you put it under the machine, that's kind of like difficult, right?
Yeah.
Okay.
It's difficult.
But it's still wholly isolated from the machine in terms of vibration, not entering the machine frame.
Yeah. And also the performance of our temperature management is the same like the micro HD.
Very cool.
A little bit more coolant.
Yeah, okay. It's a little bit larger as well. My machine has been crying after coolant for the past, I would say, 4 or 5 machines, the Fortis I'm working on. And the little bit more I always tell Josef from construction. I'm like, "Josef, it's asking for coolant. Where do I put coolant in?" And he's like, "You still have time." So, yeah. Maybe let's quickly chat about the design of the machine. Because, I mean, I've seen it, and we're definitely not going to post a picture before Emo about it, so you just need to explain it a little bit. But it's also pretty special, isn't it?
It is pretty special, and I think we can be proud of the design.
I mean, this is the moment where we can tell the internet that it's spherical in shape. You know, we have the Pyramid Nano, which was triangular, and the HD, which is boxy. So now Fortis is like a sphere, right?
Yeah.
Exactly. No.
Really, not.
It's pretty cool. If you stand in front of the machine, it's really pretty. It has some features you kind of know from HD, right?
Yeah, with the decision, we make the whole machine design similar to the Micro HD. We also decided to put some design parts from the Micro HD into the Fortis HD. Maybe if you see them together, in my opinion, now you just see a Micro HD in bigger.
Yeah. I mean, I have to say,
a little bit more pretty, but bigger.
I mean, I spent the past 5 weeks now milling on Fortis, and I looked at spindle hours today. I've done over 450 spindle hours in that time, so I'd say I have quite a heavy use on that machine already. And I have to say, what I find exceptional about that machine is it feels completely like an HD. It's just like, and this is something Simon and I talked about extensively in the last podcast, but it's just like that magic of the HD, it's there as well. And I think this is the biggest kudos I can give you, building a machine which is more than twice the size. I mean, we are always talking about it's more than twice the size, but this means for the volume of the machine and all of the errors that can happen, that it's more like 6 times as large or even more. And if you think about that, it's amazing that you managed to scale that up by not scaling that up, and it feels exactly as magical.
Not scaling up the errors.
Yeah, exactly. Not scaling up the errors. So from my side, this is a huge win for Kern and also for your team. That just like it feels like an HD.
It's nice to hear. So I think we made the right decision to build it like an Micro HD.
Yeah.
And it is like a Micro HD.
Yeah. Before we wrap up, maybe looking back on that project, what would you change if you had to do it again?
I would say in technical detail, I can't say what I would do different, but maybe in the team structure, I would change a little bit. Maybe at the beginning, smaller team with 1 or 2 people who have a wider knowledge. For example, that somebody is can do something with electronics and mechanics, or calculating and designing, this is
to move a bit quicker in the beginning.
To move a bit quicker, to keep the interfaces between the people small. To decrease the amount of meetings you need, because you have to spend a lot of time if you want to do it good. You have to prepare for the meeting, and then you have it, and later.
Okay.
So I think we have to be faster with the first prototype.
Okay, yeah.
To make more and faster improvements when we hit the market.
Okay.
Till we hit the market.
Okay. Yeah. I think the last real content question, because before we have to discuss a couple other things, is would you do it again? Would you consider doing another, like leading another development project at Kern?
At this moment, I can't give you an answer for that.
Okay. That is totally fine. Before we wrap it up, are you going to be at EMO?
I will be there.
Will you be at the open house day in Chicago as well?
No.
No. So Emo.
I will be there from Monday till Wednesday.
Monday till Wednesday. So, dear listeners, I will be posting a picture of Christian with this podcast.
He won't do this.
Yeah, he wanted that. No, he didn't want that. But he's gonna be at the Kern booth. You can talk to him. He's super cool. He knows so much. He can explain to you about the machine. Emo is in the middle of September. I think it's starting at the 15th of September, 14th?
22th.
22nd?
22nd, yeah.
22nd, okay.
22nd till 26th September.
Nice, you know it better than me. Very good. Christian will be there Monday till Wednesday. I will also be there Monday till Wednesday, driving back on
Tim
Thursday.
also.
Yeah, nice, okay. We will all be there, come up, chat with technical people, talk to them. I think everybody who has worked on the project is really enthusiastic about it and what they made there. Christian, thanks a lot for your time. Thanks for chatting with us. And until your next episode.
We'll see if it happens.